The Avro Lancaster is a British four-engined Second World War heavy bomber designed and built by Avro for the Royal Air Force. It first saw active service with RAF Bomber Command in 1942 and, as the strategic bombing offensive over Europe gathered momentum, it became the main heavy bomber used by the RAF, the RCAF, and squadrons from other Commonwealth and European countries serving within the RAF, overshadowing its close contemporaries the Handley, Halifax and short Stirling. The Lanc, as it was affectionately known, thus became the most famous and most successful of the Second World War night bombers, delivering 608,612 long tons of bombs in 156,000 sorties. The Lancaster, an evolution of the troublesome Avro Manchester, was designed by Roy Chadwick and was powered by 4 Rolls-Royce Merlins, or, in one version, Bristol Hercules engines. A long, unobstructed bomb bay meant that the Lancaster could take the largest bombs used by the RAF, including the 4,000 lb, 8,000 lb, and 12,000 lb blockbusters, loads often supplemented with smaller bombs or incendiaries. The versatility of the Lancaster was such that it was chosen to equip 617 Squadron, and was modified to carry the Barnes-Wallis-designed upkeep bouncing bomb for Operation Chastise, the attack on Germany's Ruhr Valley dams. Although the Lancaster was primarily a night bomber, it excelled in many other roles, including daylight precision bombing. In the latter role some Lancasters were adapted to carry the 12,000 lb tallboy and, ultimately, the 22,000 lb Grand Slam earthquake bombs. As early as 1943, the Lancaster was converted to become an engine test bed for the Metropolitan Vickers F2 turbojet. Lancasters were later used to test several different engines, including the Armstrong Siddeley Mamba and Rolls-Royce Dart turboprops, and the Avro Canada Orunda and STAL D'Auvergne turbojets. Post-war, the Lancaster was supplanted as the RAF's main strategic bomber by the Avro Lincoln, itself a larger permutation of the Lancaster. Instead, the Lancaster took on the role of long-range anti-submarine patrol aircraft and air-sea rescue. It was also used in roles as diverse as photo reconnaissance and aerial mapping, as a flying tanker for aerial refueling, and as the Avro Lancastrian, a long-range, high-speed transatlantic passenger and postal delivery airliner. In March 1946, a Lancastrian of BSAA flew the first scheduled flight from the then new London Heathrow Airport. Design and development. The origins of the Lancaster stem from a twin-engine bomber design submitted to meet Air Ministry specification pages 13/36, which was for a new generation of twin-engined medium bombers for worldwide use. The engine specified is the Rolls-Royce Vulture. The resulting aircraft was the Manchester, which, although a capable aircraft, was underpowered and troubled by the unreliability of the Vulture engine. Only 200 Manchesters were built, with the type withdrawn from service in 1942. Avro's chief designer, Roy Chadwick, was already working on an improved Manchester design using 4 of the more reliable, but less powerful Rolls-Royce Merlin engines on a larger wing. The aircraft was initially designated Avro Type 683 Manchester III, and later renamed the Lancaster. The prototype aircraft PT-308 was assembled by Avro's experimental flight department at Manchester's Ringway Airport. Test pilot H.A. Bill Thorne took the controls for its first flight at Ringway, on Thursday 9 January 1941. The aircraft proved to be a great improvement on its predecessor, being one of the few warplanes in history to be right from the start. Its initial 3-fin tail layout, a result of the design being adapted from the Manchester I, was quickly changed on the second prototype DG595 and subsequent production aircraft, to the familiar twin-fin specification also used on the later Manchesters. Some of the later orders for Manchesters were changed in favour of Lancasters. The designs were very similar and both featured the same distinctive greenhouse cockpit, turret nose, and twin tail. The Lancaster discarded the stubby central third tail fin of the early Manchesters and used the wider span tail plane and larger elliptical twin fins from the later Manchester IA. The Lancaster is a mid-wing cantilever monoplane with an oval all-metal fuselage. The wing was constructed in 5 main sections, the fuselage in 5 sections. All wing and fuselage sections were built separately and fitted with all the required equipment before final assembly. The tail unit had twin elliptical fins and rudders. The Lancaster was initially powered by four wing-mounted Rolls-Royce Merlin piston engines driving 13 ft diameter de Havilland Hydromatic 3-bladed air screws. It had retractable main landing gear and fixed tail wheel, with the hydraulically operated main landing gear raising rearwards into the inner engine nacelles. The majority of Lancasters built during the war years were manufactured by Avro at their factory at Chadderton near Oldham, Greater Manchester, and test-flown from Woodford Aerodrome in Cheshire. Other Lancasters were built by Metropolitan Vickers, and Armstrong Whitworth. The aircraft was also produced at the Austin Motor Company Works in Longbridge, Birmingham, later in the Second World War on postwar by Vickers Armstrongs at Chester as well as at the Vickers Armstrong factory, Castle Bromwich, Birmingham. Only 300 of the Lancaster B2 fitted with Bristol Hercules engines were constructed. This was a stopgap modification caused by a shortage of Merlin engines as fighter production was of higher priority. Many BIIs were lost after running out of fuel. The Lancaster B3 had Packard Merlin engines but was otherwise identical to contemporary BIs, with 3,030 BIIs built, almost all at Avro's Newton Heath factory. The BI and B3 were built concurrently, and minor modifications were made to both marks as new batches were ordered. Examples of these modifications were the relocation of the pitot head from the nose to the side of the cockpit, and the change from de Havilland needle blade propellers to Hamilton Standard or Nash Kelvinator-made paddle blade propellers. Of later variants, only the Canadian-built Lancaster BX, manufactured by Victory Aircraft in Moulton, Ontario, was produced in significant numbers. A total of 430 of this type were built, earlier examples differing little from their British-built predecessors, except for using Packard-built Merlin engines and American-style instrumentation and electrics. The final production version was the Mark 7 and was made by the Austin Motor Company at their Longbridge factory. The main design difference with the Mark 7 was the use of the American-built Martin dorsal gun turret in place of the English Nash and Thompson 1. They had to be mounted slightly further forward on the fuselage for weight balance. All were produced too late for the war in Europe and were tropicalized and upgraded as the Mark 7 for use in the Far East against Japan. A total of 7,377 Lancasters of all marks were built throughout the duration of the war, each at a 1943 cost of £45 to £50,000. Crew accommodation. Starting at the nose, the bomb aimer had two positions to man. His primary location was lying prone on the floor of the nose of the aircraft, with access to the bomb sight controls facing forward, with the bomb sight computer on his left and bomb release selectors on the right. He also used his view out of the large transparent perspex nose cupola to assist the navigator with map reading. To man the Fraser-Nash FN5 nose turret, he stood up placing himself in position behind the triggers of the twin .303 in guns. Ammunition for the turret was 1,000 rounds per gun. The bomb aimer's position contained the nose emergency hatch in the floor. At 22 inches by 26.5 inches it was difficult to exit through while wearing a parachute. Compared with other contemporary aircraft, the Lancaster was not an easy aircraft to escape from. In a Halifax, 25% of downed aircrew bailed out successfully, and in American bombers it was as high as a 50% success rate while only 15% of the Lancaster crew were able to bail out. Operational research experts attempted unsuccessfully to have the escape hatch enlarged. Moving back, on the roof of the bomb bay the pilot and flight engineer sat side by side under the expansive canopy, with the pilot sitting on the left on a raised portion of the floor. The flight engineer sat on a collapsible seat to the pilot's right, with the fuel selectors and gauges on a panel behind him and to his right. The pilot and other crew members could use the panel above the cockpit as an auxiliary emergency exit while the mid-upper gunner was expected to use the rear entrance door to leave the aircraft. The tail gunner escaped by rotating his turret to the side and dropping out backwards through the two rear turret doors. Behind the pilot and flight engineer, and behind a curtain fitted to allow him to use light to work, sat the navigator. His position faced to port with a chart table in front of him. An instrument panel showing the airspeed, altitude, and other information required for navigation was mounted on the side of the fuselage above the chart table. The wireless operator's radios were mounted on the left-hand end of the chart table, facing the rear of the aircraft. Behind these and facing forwards, the wireless operator sat on a seat at the front of the main spar. On his left was a window, and above him was the astrodome, used for visual signaling and by the navigator for celestial navigation. Behind the wireless operator were the two spars for the wing, which created a major obstacle for crew members moving down the fuselage even on the ground. On reaching the end of the bomb bay, the floor dropped down to the bottom of the fuselage, and the mid-upper gunner's turret was reached. His position allowed a 360-degree view over the top of the aircraft, with two Browning .303 Mark IIs to protect the aircraft from above and to the side. The mid-upper gunner sat on a rectangle of canvas that was slung beneath the turret and would stay in position throughout the flight. Ammunition for the turret was 1,000 rounds per gun. To the rear of the turret was the side crew door, on the starboard side of the fuselage. This was the main entrance to the aircraft, and also could be used as an emergency exit. The Elson chemical toilet, a type of aircraft lavatory, was located near the spars for the tailplane. At the extreme tail end of the fuselage, the rear gunner sat in his exposed position in the tail turret, which was entered through a small hatch in the rear of the fuselage. Depending on the size of the rear gunner, the area was so cramped that the gunner would often hang his parachute on a hook inside the fuselage, near the turret doors. Neither the mid-upper nor the rear gunner's position was heated, and the gunners had to wear electrically heated suits to prevent hypothermia and frostbite. Many rear gunners insisted on having the center section of perspex removed from the turret to improve visibility. The transparencies were difficult to see through at night, particularly when trying to keep watch for enemy night fighters that appeared without notices down and below the aircraft when getting into position to open fire. This removal of perspex from the turret was called the Granston Lodge modification. Ammunition for the tail turret was 2,500 rounds per gun, due to the weight the ammunition being stored in tanks situated near the mid-upper turret's position and fed rearward in runways down the back of the fuselage to the turret. Armament. Defensive armament. The Avro Lancaster was initially equipped with 4 Nash and Thompson Fraser Nash hydraulically operated turrets mounted in the nose, tail, mid-upper and underside. The original tail turret was equipped with 4 Browning .303 Mark II machine guns and all other turrets with 2 such machine guns. Nose turret. Only the FN-5A nose turret, which was similar to the FN-5 used on the preceding Avro Manchester, the Vickers Wellington and the short Stirling, remained unchanged during the life of the design, except in instances where it was removed entirely. Ventral turret. The ventral FN-64 turret quickly proved to be dead weight, being both difficult to sight because it relied on a periscope which limited the gunner's view to a 20-degree arc, and too slow to keep a target within its sights. Aside from early Bs and the prototype BIIs, the FN-64 was almost never used. When the Luftwaffe began using Schra currency GE music to make attacks from below in the winter of 1943/1944, modifications were made, including downward observation blisters mounted behind the bomb aimer's blister and official and unofficial mounts for .50 in machine guns or even 20 cannon, firing through the ventral holes of the removed FN-64. The fitting of these guns was hampered as the same ventral position was used for mounting the H-2S blister, which limited installations to those aircraft fitted with bulged bomb bays which interfered with the H-2S. Mid-upper turret. The mid-upper was an FN-50 on early examples and a very similar FN-150 with improved sights and controls on later examples. On all but the earliest examples, this turret was surrounded by a coaming which provided a track for a cam-operated interrupter device which prevented the gunner from shooting the tail of his own aircraft. The MKV and late MKX Lancasters used the heavier electrically controlled Martin 250 CE-23A turret equipped with 2.50-inch machine guns, which was mounted further forward to preserve the aircraft's longitudinal balance, and because it had an internal mechanism to prevent firing on the aircraft itself, it did not require a coaming. Other experimental turrets were tried out, including the FN-79 and the Bolt and Paul type H-barbette system. Tail turret. The tail turret was the most important defensive position and carried the heaviest armament. Despite this, the turrets used, starting with the FN-20, were never entirely satisfactory and numerous designs were tried. The FN-20 was replaced by the very similar FN-120, which used an improved gyroscopic gun sight. Gunners using both the FN-20 and 120 removed perspex and armor from the turret to improve visibility, but trials by the RAF showed that a Mosquito night fighter was still able to get within a very short distance of the tail gunner without being spotted, confirming what the Luftwaffe had already realized. The Rose turret attempted to improve on the FN turrets by being completely open to the rear and by being fitted with 2.50-inch machine guns, and was installed in a small number of Lancasters but never became common. Ultimately, radar, rather than improved visibility, made the turret more effective. The FN-121 was the automatic gun-laying turret, an FN-120 fitted with village and gun-laying radar. Aircraft fitted with village-in were used as bait, flying behind the main formations to confront the night fighters that followed the formations and shot down stragglers. This significantly reduced operational losses. And gun-laying radar was added to the last versions of the turret. Before the end of the war, Lancasters built in the UK standardised on the FN-82 fitted with 2.50-inch machine guns and fitted with gun-laying radar as production allowed, which was also used on early models of the Avro Lincoln. The disadvantage of all radar and radio transmitting systems is that attacking forces can locate aircraft by picking up transmissions. Later in the war, Freeman Dyson made a case for removing all the Lancaster's defensive armament, arguing it would reduce the loss rate by increasing the Lancaster's speed by up to 50 mph, and thus make it harder to shoot down. This became even more important when Dyson and Michael Illin concluded that some of the German night fighters were using Schreck-currency GE Music upward-firing guns, as the Lancaster had no ventral gun turret to defend itself, although any defense would depend on the crew detecting the attack from underneath. Dyson considered that the modification would be justified even if the aircraft loss rate was unchanged, as two defensive air gunners would not be required, reducing human losses. The case for speed over defensive armament was supported by the Mosquito, whose loss rates were far lower than the Lancasters. As an example, during the Battle of Berlin the average loss rate of the heavy bombers was 5.1%, whereas for Mosquitoes it was 0.5%, though a speed-optimized Lancaster would still be up to 50 mph slower than a Mosquito and unlikely to match its low loss rates. Bombs. An important feature of the Lancaster was its unobstructed 33 LFT long bomb bay. At first, the heaviest bomb carried was the 4000 lb high-capacity HC Cookie. Bulge doors were added to 30% of bays to allow the aircraft to carry 8000 lb and later 12,000 lb Cookies. The Lancaster also carried a variety of smaller weapons, including the small bomb container which held 236 4 lb or 2430 lb incendiary and explosive incendiary bomblets, 500 lb and 1000 lb general-purpose high-explosive bombs, 1850 lb parachute-deployed magnetic or acoustic mines, or 2000 lb armor-piercing bombs, 250 lb semi-armor-piercing bombs, used up to 1942 against submarines. Post-1942, 250 lb or 500 lb anti-submarine depth charges. In 1943 617 Squadron was created to carry out Operation Chastise, the raid against the Ruhr dams. This unit was equipped with BE, officially designated the Type 464, modified to carry the 9250 lb upkeep bouncing bomb. The bomb bay doors were removed and the ends of the bomb bay were covered with fairings. Upkeep was suspended on laterally pivoted, V-shaped struts which sprang apart beamwise when the bomb release button was pressed. A drive belt and pulley to rotate the bomb at 5:00 p.m. was mounted on the starboard strut and driven by a hydraulic motor housed in the forward fairing. The mid-upper turret was removed and a more bulbous bomb aimers blister was fitted. This, as Mod 780, later becoming standard on all Lancasters, while the bomb sight was replaced by a simple aiming device. Two Aldous lights were fitted in the rear bomb bay fairing. The optimum height for dropping upkeep was 60 ft and, when shone on the relatively smooth waters of the dam's reservoirs, the light beams converged into a single spot when the Lancaster was flying at the correct height. Towards the end of the war, attacking special and hardened targets, other variants of BI specials were modified to carry the 21 ft long 12,000 lb tallboy, or 25.5 ft long 22,000 lb Grand Slam earthquake bombs. To carry the Grand Slam, extensive modifications to the aircraft were required. The modifications included removal of the dorsal turret and the removal of two guns from the rear turret. Removal of the cockpit armor plating and installation of Rolls-Royce Merlin Mk24 engines which had better takeoff performance. The bomb bay doors were removed and the rear end of the bomb bay cut away to clear the tail of the bomb. Later the nose turret was also removed to further improve performance. The undercarriage was strengthened and stronger manheels, later used by the Avro Lincoln, were fitted. Specific bomb loads were standardized and given code names by Bomber Command. Bomb sights used on Lancasters included, Mark 9 course setting bomb sight. This was an early preset vector bomb sight that involved squinting through wires that had to be manually set based on aircraft speed, altitude and bomb load. The sight lacked tactical flexibility as it had to be manually adjusted if any of the parameters changed and was soon changed in favor of more advanced designs. Mark 14 bomb sight, a vector bomb sight where the bomb aimer input details of the bomb load, target altitude and wind direction and the analog computer then continuously calculated the trajectory of the bombs and projected an inverted sword shape onto a sighting glass on the sighting head. Assuming the sight was set correctly, when the target was in the crosshairs of the sword shape, the bomb aimer would be able to accurately release the bombs. T-1 bomb sight, a Mark 14 bomb sight modified for mass production and produced in the USA. Some of the pneumatic gyro drives on the Mk14 sight were replaced with electronic gyros and other minor modifications were made. Stabilizing automatic bomb sight, also known as SABS, this was an advanced bomb sight mainly used by 617 Squadron for precision raids. Like the American Norden bomb sight, it was a tachometric sight. Radio, radar and countermeasures equipment, the Lancaster had a very advanced communications system for its time. Most British-built Lancasters were fitted with the R1155 receiver and T1154 transmitter, whereas the Canadian-built aircraft and those built for service in the Far East had American radios. These provided radio direction finding, as well as voice and Morse capabilities. H2S, 3 GHz frequency, ground-looking navigation radar system, eventually, it could be homed in on by the German night fighters' FUG 350 Naxos receiver and had to be used with discretion. This is the large blister under the rear fuselage on later Lancasters. Fishpond, an add-on to H2S that provided additional coverage of the underside of the aircraft to display attacking fighters on an auxiliary screen in the radio operator's position. Moniker, a rearward-looking radar to warn of night fighter approaches. However, it could not distinguish between attacking enemy fighters and nearby friendly bombers and served as a homing beacon for suitably equipped German night fighters. Once this was realized, it was removed altogether. G, a receiver for a navigation system of synchronized pulses transmitted from the UK, aircraft calculated their position from the time delay between pulses. The range of G was 3-400 mi. G used a whip aerial mounted on the top of the fuselage ahead of the mid-upper turret. Boozer, a system of lights mounted on the aircraft's instrument panel that lit up when the aircraft was being tracked by WA-1/4 LZBURG ground radar and Liechtenstein airborne radar. In practice it was found to be more disconcerting than useful, as the lights were often triggered by false alerts in the radar signal-infested skies over Germany. Oboe, a very accurate navigation system consisting of a receiver transponder for 2 radar stations transmitting from widely separated locations in southern England which, when used together, determined the aircraft's position. The system could only handle 1 aircraft at a time, and was fitted to a Pathfinder aircraft, usually a fast and maneuverable Mosquito which marked the target for the main force rather than a Lancaster. GH, similar to oboe but with a transponder on the ground allowing more aircraft to use the systems simultaneously. GH aircraft were usually marked with 2 horizontal yellow stripes on the fins. Village Inn, a radar-aimed gun turret fitted to some Lancaster rear turrets in 1944. Identifiable by a dome mounted below the turret. Airborne Cigar, this was only fitted to the Lancasters of 101 Squadron. It had 3 large aerials, 2 sticking out of the top of the fuselage and 1 under the bomb aimer's position. These aircraft carried a German-speaking crew member on board and were used to jam radio to German night fighters and feed false information on Allied bomber positions to them. Due to the nature of the equipment, the enemy was able to track the aircraft and due to this, 101 suffered the highest casualty rate of any squadron. Fitted from about mid-1943, they remained until the end of the war. Tinsel, an audio microphone installed in the nacelle of one of the engines that allowed the wireless operator to transmit engine noise on the German night fighter control voice frequencies. Operational history: Second World War. The first RAF squadron to convert to the Lancaster was No. 44 Squadron RAF in early 1942. Lancasters flew 156,000 sorties and dropped 608,612 or longer tons of bombs between 1942 and 1945. Just 35 Lancasters completed more than 100 successful operations each, and 3,249 were lost in action. The most successful survivor completed 139 operations, and was scrapped in 1947. Lancasters took part in the devastating round-the-clock raids on Hamburg during Air Chief Marshal Harris's Operation Gomorrah in July 1943. A famous Lancaster bombing raid was the 1943 mission, codenamed Operation Chastise, to destroy the dams of the Ruhr Valley. The operation was carried out by 617 Squadron in modified MKIIs carrying special drum-shaped bouncing bombs designed by Barnes Wallis. The story of the operation was later made into a film, The Dam Busters. Also famous was a series of Lancaster attacks using tallboy bombs against the German battleship at Tirpitz, which first disabled and later sank the ship. Adolf Galland considered the Lancaster to be the best night bomber of the war, as did his adversary, Arthur Bomber Harris, who referred to it as the RAF Bomber Command's shining sword. Lancasters from Bomber Command were to have formed the main strength of Tiger Force, the Commonwealth bomber contingent scheduled to take part in Operation Downfall, the codename for the planned invasion of Japan in late 1945. Together with the new Avro Lincoln and Liberators, they would have operated from bases on Okinawa. The invasion was made unnecessary by the Japanese surrender. RAF Lancasters dropped food into the Holland region of the occupied Netherlands, with the acquiescence of the occupying German forces, to feed people who were in danger of starvation. The mission was named Operation Manna after the food manna which is said to have miraculously appeared for the Israelites in the Book of Exodus. The aircraft involved were from 1, 3, and 8 groups, and consisted of 145 Mosquitoes and 3,156 Lancasters, flying between them a total of 3,298 sorties. The first of the 2 RAF Lancasters chosen for the test flight was nicknamed Bad Penny from the old expression, "A bad penny always turns up." This bomber, with a crew of 7 men, took off in bad weather on the morning of April 29, 1945 without a ceasefire agreement from the German forces, and successfully dropped its cargo. A development of the Lancaster was the Avro Lincoln bomber, initially known as the Lancaster 4 and Lancaster V. These 2 marks became the Lincoln B1 and B2 respectively. A civilian airliner was based on the Lancaster, the Lancastrian. Other developments were the York, a square-bodied transport and, via the Lincoln, the Shackleton, which continued in airborne early warning service up to 1992. Post-war, in June 1947, the Argentine Air Force received 15 Lancasters. During its Argentine service, Lancasters saw limited use in military coups, owing to the small number there. A total of 59 Lancaster Bs and Bvia were overhauled by Avro at Woodford and Langer and delivered to the Aéronavale during 1952-53. These were flown until the mid-1960s by 4 squadrons in France and New Caledonia in the maritime reconnaissance and search and rescue roles. Beginning in 1946, Lancaster MKXs were modified for service with the Royal Canadian Air Force. 14 were modified for aerial and photo reconnaissance work and performed much of the mapping of northern Canada until as late as 1962. Throughout the 1950s the RCAF operated 70 modified Lancasters, designated Lancaster 10 Mr. MPs, as maritime reconnaissance and patrol aircraft in an anti-submarine role. Modifications involved the installation of radar and sonar buoy operators' positions, removal of the rear and mid-upper gun turrets, installation of a 400-gallon fuel tank in the bomb bay to increase the patrol range, upgraded electronics, radar, and instrumentation, and a cooking stove in the center section. They served throughout the 1950s, when they were replaced by the Lockheed Neptune and Canada Argus. Civil conversions continued post-war. In 1946, 4 Lancasters were converted by Avro at Bracebridge Heath, Lincolnshire as freighters for use by British South American Airways, but proved to be uneconomical, and were withdrawn after a year in service. In addition, 4 Lancaster IIIs were converted by Flight Refuelling Limited as 2 pairs of tanker and receiver aircraft for development of in-flight refueling. In 1947, 1 aircraft was flown non-stop 3,459 mi from London to Bermuda. Later the 2 tanker aircraft were joined by another converted Lancaster and used in the Berlin airlift, achieving 757 tanker sorties. From 1943 to 1947 the Canadian government Transatlantic Air Service provided a transatlantic military passenger and postal delivery service using a modified long-distance transport version of the Lancaster Mark X. 9 of these aircraft were produced, referred to as Lancaster XPPs, and each was equipped with rudimentary passenger facilities. The inaugural flight from Dorval to Prestwick, Scotland on July 22, 1943, was completed non-stop in a record 12:26 hours. The average crossing time was about 13:25 hours. By the end of the war, these aircraft had completed hundreds of trips across the Atlantic. CGTAS ushered in the era of commercial air travel across the North Atlantic, and in 1947 the service became part of Trans-Canada Airlines, which carried paying civilian passengers in the Lancaster XPPs until they were replaced by Douglas DC-4s in 1947. Variants, BI, media related to Avro Lancaster B Mark I at Wikimedia Commons. The original Lancasters were produced with Rolls-Royce Merlin 20 engines and SU carburetors. Minor details were changed throughout the production series. For example, the pitot head design was changed from being on a long mast at the front of the nose to a short fairing mounted on the side of the fuselage under the cockpit. Later production Lancasters had Merlin 22 and 24 engines. No designation change was made to denote these alterations. BI Special, media related to Avro Lancaster BI Special at Wikimedia Commons. 32 aircraft were adapted to take first the Super Heavy tallboy, and then Grand Slam bombs. Uprated engines with paddle-bladed propellers gave more power, and the removal of gun turrets reduced weight and gave smoother lines. For the tallboy, the bomb bay doors were bulged. For the Grand Slam, they were removed completely and the area faired over. For some tallboy raids, the mid-upper turret was removed. This modification was retained for the Grand Slam aircraft, and in addition the nose turret was later removed. 2 airframes were modified to carry a dorsal saddle tank with 1,200 gal mounted aft of a modified canopy for increasing range. Number 1577 SD flight tested the aircraft in India and Australia in 1945 for possible use in the Pacific, but the tank adversely affected handling characteristics when full, and an early type of flight refueling designed in the late 1930s for commercial flying boats was later used instead. Pier 1, B-1 modified for photographic reconnaissance, operated by RAF No. 82 and No. 541 squadrons, wartime. All armament and turrets were removed with a reconfigured nose and a camera carried in the bomb bay. The type was also operated by 683 Squadron from circa 1950 for photographic reconnaissance based at Aden and subsequently Habbaniya in Iraq until disbanded November 30, 1953. BI, In anticipation of the needs of the Tiger Force operations against the Japanese in the Far East, a tropicalized variant was based on late production aircraft. The BI had modified radio, radar, navaids, and a 400 gal tank installed in the bomb bay. Most were painted with white upper surfaces and black undersides with a low demarcation between the colors. BII, media related to Avro Lancaster B Mark II at Wikimedia Commons. Bristol Hercules powered variant, of which 300 were produced by Armstrong Whitworth. One difference between the two engine versions was that the 6 had manual mixture control, requiring an extra lever on the throttle pedestal. Very early examples were fitted with an FN-64 ventral turret. However, these were quickly removed due to problems with aiming the turret through its periscope, and inadequate traverse speed. Due to the Luftwaffe's recurrency GE music attacks, a variety of unofficial field modifications were made, including fitting of 20-on cannon or a .50-inch machine gun in the open hull where the FN-64 had been installed, before an official modification fitted with a .303-inch machine gun was authorized for the same location, though not in all aircraft. These were rarely installed on other variants as the H-2S radar that was not used on the B-2 was mounted there. 3 types of bulged bomb bay were used on the B-2, the prototype having a narrow bulge running from just aft of the cockpit to the end of the bomb bay, while early production examples had a full-width bulge that ran the same length, and on late production examples the bomb bay doors were prominently bulged throughout their length. B. Media related to Avro Lancaster B Mark III at Wikimedia Commons. This variant, which was built concurrently with the BI and was indistinguishable externally from that variant, was fitted with Packard-built Merlin engines. The Packard Merlins used Bendix, Stromberg pressure injection carburetors, requiring the addition of slow-running cutoff switches in the cockpit. B3, media related to Avro Lancaster B3 Special at Wikimedia Commons. Known at the time of modification as the Type 464 Provisioning Lancaster, 23 aircraft of this type were built to carry the upkeep bouncing bomb for the dam-busting raids. The bomb bay doors were removed and Vickers-built struts to carry the bomb were fitted in their place at Woodford Aerodrome near Stockport where the workers worked day and night. A hydraulic motor, driven by the pump previously used for the mid-upper turret was fitted to spin the bomb. Lamps were fitted in the bomb bay and nose for the simple height measurement system which enabled the accurate control of low flying altitude at night. The mid-upper turret was removed to save weight and the gunner moved to the front turret to relieve the bomb aimer from having to man the front gun so that he could assist with map reading. AS-3, B3 modified for air sea rescue, with 3 dipole ventral antennas fitted aft of the radome and carrying an airborne lifeboat in an adapted bomb bay. The armament was often removed and the mid-upper turret fared over, especially in post-war use. Observation windows were added to both sides of the rear fuselage, a port window just forward of the tailplane and a starboard window into the rear access door. A number of AS-3 conversions were fitted with Lincoln-style rudders. GR3/Mr. 3, BA modified for maritime reconnaissance. BIV. The BIV featured an increased wingspan and lengthened fuselage, a new bolt-and-pull F turret with framed bay window nose glazing. The prototypes were powered by 2-stage Merlin 85s inboard and later, Merlin 68s on the outboard mounts. Because of the major redesign, the aircraft was quickly renamed Lincoln B1. BV, increased wingspan and lengthened fuselage, 2-stage Merlin 85s. Renamed Lincoln B2, BVI, 9 aircraft converted from BAES. Fitted with Merlin 85/87 which had 2-stage superchargers, giving much improved high-altitude performance. The B6 could achieve a maximum speed of 313 mph at 18,200 ft at 65,000 lb takeoff weight and a service ceiling of 28,500 ft at the same weight. Climb to 28,000 ft at 65,000 lb takeoff weight was accomplished in 44.8 minutes with a maximum climb rate of 1,080 foot per minute at 1,000 ft. A Lancaster B6 was dived to a maximum indicated speed of 350 mph, or Mach 0.72 at 25,000 ft in June 1944. The Merlin 85/87 series engines were fitted with annular cowlings similar to the Avro Lincoln, and three-bladed paddle-type propellers were fitted. These aircraft were only used by Pathfinder units. By No. 7 Squadron RAF, No. 83 Squadron RAF, No. 405 Squadron RCAF, and by No. 635 Squadron RAF. Often used as a master bomber, the B-6s were allocated to RAF Bomber Command, apart from two that were retained by Rolls-Royce for installation and flight testing. Their dorsal and nose turrets were removed and fed over. The more powerful engines proved troublesome in service and were disliked by ground maintenance staff for their rough running and propensity to surge and hunt, making synchronization impossible. This was caused by variations in the fuel-air mixture and over time would damage the engine. The B-6 was withdrawn from operational service in November 1944, and surviving aircraft were used by Rolls-Royce, the Royal Aircraft Establishment, and the Bomb Ballistics Unit for various testing and experimental duties. BVRI, media related to Avro Lancaster B Mark 7 at Wikimedia Commons. The BVRI was the final production version of the Lancaster. The Martin 250 CE mid-upper turret was moved slightly further forward than on previous Marks, and the Nash & Thompson FN-82 tail turret with twin 0.50 in Browning machine guns replaced the FN-20 turret with four Browning .303 Mark IIs. The Martin turret carried two 0.5-inch Browning Mark II machine guns which packed much more punch than the .303s of the older turret. However, these Martin turrets arrived too late for inclusion in the first 50 aircraft built by Austin, and these were therefore referred to as Mark 7. Another 180 true Mark VIIs were built at Longbridge. Two sub-variants of the 7 existed, the Far East for use in tropical climates and the B-7 Western Union, which went to France. BX, media related to Avro Lancaster B Mark X at Wikimedia Commons. The BX was a Canadian-built BE with Canadian and US-made instruments and electrics. On later batches, the heavier Martin 250 CE was substituted for the Nash & Thompson FN-50 mid-upper turret, mounted further forward to maintain center of gravity balance. Canada was a long-term operator of the Lancaster, using modified aircraft after the war for maritime patrol, search and rescue and photo reconnaissance until 1964. The last flight by the RCAF was by FL Lynn Garrison in KB 976, on July 4, 1964 at the Calgary International Air Show. During the Second World War, Canada's Victory aircraft was responsible for the development of the Lancastrian, which was duly designated the XPP for Mark 10 passenger plane. 6 were built for Trans-Canada Airlines. Post-war, the RCAF modified the BX to fill a variety of roles, with specific designations for each role. These included 10AR, Area Reconnaissance Electronic Warfare Aircraft with lengthened nose; 10BR, Bomber Reconnaissance; 10DC, Drone Controller with Ryan 5B drones, 2 modified; 10 Mr., Maritime Reconnaissance or Maritime Patrol Anti-Submarine Warfare Aircraft; 10N, Navigational Trainer; 10O, Orenda jet engine test bed for the engine used in the RCAF 100. 10P, Photo Reconnaissance Mapping Duties; 10 Storadians, Air-Sea Search and Rescue Aircraft, 8 modified. 10S and 10U, Standard aircraft and unmodified aircraft held in storage for future use or for transfer to museums. BXV, as per Lancaster BIV Lincoln B1 but built in Canada and renamed Avro Lincoln 15. One example built before order cancelled when war ended. Operators: an Argentina, a Australia, a Canada, a Egypt, a France, a Poland, a Soviet Union, a Sweden, a New Zealand, a United Kingdom. Surviving aircraft. Of the 17 surviving and largely intact Lancasters known to exist, 2 are airworthy. One, based in the UK, is operated by the Battle of Britain Memorial Flight, and the other is in Canada, operated by the Canadian Warplane Heritage Museum. In August 2014, the Canadian aircraft is due to visit the UK for a series of joint displays with the BBMF aircraft. Specifications. Data from Avro aircraft since 1908, general characteristics, crew, 7 Pilot, Flight Engineer, Navigator, Bomb Aimer, Nose Gunner, Wireless Operator, Mid-Upper and Rear Gunners. Length, 69 ft/4 in, Wingspan, 102 ft/0 in, Height, 20 ft/6 in, Wing Area, 1,297 square feet, Empty Weight, 36,457 lb, Loaded Weight, 68,000 lb, Max Takeoff Weight, 72,000 lb with 22,000 bomb. Power Plant, 4 Rolls-Royce Merlin 20 liquid-cooled V12. Engines, 1,280 HP each. Performance, maximum speed, 282 mph at 63,000 lb and 13,000 ft altitude. Cruise speed, 200 mph. Range, 2,530 mi. Service ceiling, 21,400 ft at 63,000 lb. Rate of climb, 720 foot per minute at 63,000 lb and 9,200 feet altitude. Armament, guns, 2 Browning .303 Mark II machine guns in nose turret. 2 Browning .303 Mark II machine guns in upper turret, and 4 Browning .303 Mark II machine guns in the rear turret. Bombs, maximum normal bomb load of 14,000 lb or 22,000 lb Grand Slam with modifications to bomb bay. Noted Lancaster pilots and crew members, Victoria Cross Awards. Many Lancaster crew members were highly decorated for actions while flying the aircraft. Amongst those who received the Victoria Cross were, Squadron Leader Ian Willoughby Bazalgette, Wing Commander Guy Gibson, Warrant Officer Norman Cyril Jackson, Pilot Officer Andrew Minarski, Squadron Leader John Daring Nettleton, Squadron Leader Robert Anthony Morris Palmer, Flight Lieutenant William Reed, Flight Sergeant George Thompson, Group Captain Leonard Cheshire. Most unusually, he did not receive the VC for any particular act, instead it was awarded for sustained courage on over 100 bombing missions. Captain Edwin Swales, other, James Bryan Tayert, recommended for VC for similar reasons as Cheshire but received third barter DSO. Notable appearances in media. The Avro Lancaster featured prominently in the 1955 film The Dam Busters, and a number of B-7 Lancasters in storage were modified to the original configuration of the B-3 for use on screen. The Lancaster also plays a central role in Bomber, the 1970 novel by Len Dayton about a night raid on a fictional German town by a formation of RAF bombers. It also featured in a 1989 British commercial for Carling Black Label Lager, which reused footage in a Dam Busters parody sequence in which a German soldier on top of a dam was catching the bombs in the manner of a football goalkeeper. The pilot of the attacking Lancaster then delivers the brand slogan, "I bet he drinks Carling Black Label." The commercial ran for many years, frequently appearing in commercial breaks during broadcasts of both the Dam Busters and of documentaries about Operation Chastise. The Avro Lancaster was also featured in the UK TV series Pathfinders, airing in 1972 and released on DVD in 2006, concentrating on the lives of the aircrew of a fictional Pathfinder squadron during the Second World War. Other films in which the Lancaster appeared include Appointment in London and The Guns of Navarone. See also: Lancaster Memorial, related development, Avro Manchester, Avro York, Avro Lancastrian, Avro Lincoln, Avro Lincolnian, Avro Tudor, Avro Shackleton, aircraft of comparable role, configuration and era, Boeing B-17 Flying Fortress, Consolidated B-24 Liberator, Focke-Wulf FW-200, Handley Page Halifax, Heinkel He-177, Junkers Ju-290, Messerschmitt Me-264, Pitliakov P-8, Piaggio Pages 108, Short Stirling, Supermarine B-12/36, Vickers Windsor, related lists, list of aircraft of World War II, list of bomber aircraft, list of aircraft of the RAF, references, notes. Citations. Bibliography. External links, documentary video depicting a Lancaster crew on a raid to Berlin, video of engine startup of preserved Lancaster Mk7NX611 Just Jane at the Lincolnshire Aviation Heritage Centre, the Lancaster Archive, Austin and Longbridge Aircraft Production, the longest Lancaster operation, 10 hours 25 minutes, History of Lancaster Mk. Bull Creek Museum, Western Australia, surviving Birmingham and Manchester made Avro Lancasters, Lancaster bomber crews and their experiences, the Lancaster's electronic equipment, 8 tons, October 1944, Popular Science article with a colour cutaway illustration, Avro 683 Lancaster, the Avro Lancaster A. 1942 flight article.